Hello friends, today I'm here to show you a really cool circuit board that this is mostly the topic called transistors. You may have heard of it, probably not, alright? But still, here I made a simple circuit with just a light bulb, motor, switch, some wires, batteries, and the transistor. A PNP type, meaning positive, negative, positive, and I'll explain that later. So, what am I going to do is when I press the switch, both of them will be on. Alright, I am back, and I'm going to explain how the transistor works. So, I'm going to tell you that there's actually two circuits from this experiment, and I'll tell you why. The reason why there's two circuits is because even without this switch, the transistor for getting to this load, the motor, will have to have, will technically meaning that the electrons will flow, right? And the other will flow too. But on the C1, we'll say that's circuit 1 and this is circuit 2, alright? On C1, it doesn't though. Because there is this area in the transistor called the depletion layer. Meaning that it won't let electrons flow. All the electrons and protons are neutral together. That means that all the electrons won't flow. So, the only way we can make it flow is when we add the negative on the base, a negative voltage on the base. And the reason why I say negative voltage is because this is a PNP. So that means there's also another called the NPN, meaning that this will be a positive voltage base and these will be negative, but it doesn't matter. It's the polarity change, so it doesn't matter about that. Besides that, all right. So when this happens, it will control the flow. That it won't let we wouldn't say control, but it won't let the flow. Like I said, the circuit 2 is controlling that because it will only let electricity flow if this was a closed circuit. So now I'm gonna make this a closed circuit. Now that rule gives it to the transistor. He's like, hey yo, I'm done with my rule. I'm gonna give my rule to yours. So now he's gonna control the flow. He's gonna distribute the electrons, which means the electrons for this circuit is I1, and the electrons for this circuit is I2. It will distribute for the motor and the light. But to tell you that I2 is much less than I1 because a motor needs a lot of electricity, while the light, it doesn't need that much. That's why this filament light will heat up a lot. If we heat up even more, if we say that I2 is much greater than I1, then it will explode, obviously. That's why we're not gonna say, yo, let's just give more electricity to this. Not gonna happen. It's gonna explode. That's why that's the key thing to the transistor. It distributes. It can be the transistor is acting like the switch now, because the switch from this gave the rule to the transistor now. That's why it distributes the electrons. And also we see, and it's like an on and off switch, really fast, and we can't even see with our own eyes. That's why we can see all the loads going together when it's on.
This is a water tap. Water enter at this end and leave at this end. This is the handle which control the flow through the tap. If we slightly open the valve of the tap, we will see water will start to flow. If we open the valve fully with the help of handle, we will see that there will be a maximum flow of water through the tape. A transistor works in a similar way. Current passing through a transistor enter at emitter terminal of the transistor and leave at collector terminal of the transistor, while the base terminal of the transistor control the current passing through the transistor. We can turn on or turn off a transistor with the help of base terminal. Now we see the animated circuit of transistor as a switch. Transistor can behave as on switch or off switch. This is transistor, this is the load, and this is the current controlling terminal of the transistor, which is called base of the transistor. If we apply a positive signal at the base of the transistor, emitter base junction will become forward bias and transistor will conduct. In this state, transistor behave like an on switch. If we remove the signal from the base, we will see that current will not pass through the transistor. In this state, transistor behave like an off switch.
So I hope you enjoyed my exclamation and seen the experiment. If you understand it, then that's great.